Good afternoon, guys. The other day I was thinking about engines and just what went into an engine and how designers and engineers and people that know a lot about engines design them so that all the parts work together properly. It's a fairly simple principle: intake, compression, combustion, and exhaust. But the way that's applied is very interesting to me. A lot of the channels that I look at where people are restoring engines or running engines, it's interesting to see how the parts work together. And one of the parts that I find interesting, among other things, are pistons. And everybody knows pistons take the combustion forces and translate them into rotary motion at the crankshaft. And the crankshaft then uses that power for a chainsaw or a lawnmower or a boat or a car or an airplane. But there are a couple of interesting features about pistons that may not be readily apparent. The piston moves up and down in the cylinder in a reciprocating motion. The crankshaft turns in a rotary motion, and the two are connected by the connecting rod. But when the piston is traveling up and down, the crankshaft is turning in a rotary motion, so the connecting rod will move at an angle relative to the piston. Which means, for example, this is the piston pin hole. So if the piston is moving up and down this way, I assume it goes up on a compression stroke, there will be a tendency for the piston to be pushed sideways in this direction. When it's pushed down by the force of the combustion, it will have a tendency to be pushed the other way. That means that on each piston there's two thrust surfaces. This is one thrust surface. This is the other thrust surface. And what keeps the piston in proper alignment in the cylinder is the cylinder skirt. And that has to be designed to keep the piston from tilting, but also not so big that there's a weight penalty. So that's an interesting design consideration. So there's the skirt, there are the lands for the piston rings, and there's the piston head. The piston head is fairly thick so it can resist the heat and forces that are put on it. I'll put this way. See if you can see inside here. Maybe not. I can do this better. But you can probably just barely see the piston pin bosses which support the piston pin in this particular piston. Now, some designers design pistons in a cam-ground shape, and that means the thrust surfaces are close fitting, but there's a little bit of clearance on the anti-thrust surfaces, so when the piston heats up, it expands and takes up the entire surface better. This is a big piston. This is from a Pratt & Whitney radial aircraft engine. It was a 9-cylinder aircraft engine, and as you can see, there are one oil control ring and 3 compression rings. There's also a lower compression ring. These pistons were arranged in a circular fashion, so some of the pistons would actually be upside down relative to the engine. And inside, let me see if you can see that. Not real well, but you can see the piston pin bosses. They're quite substantial, and you can just barely see on the inside there are fins that are actually used for cooling the piston crown. Another thing about this particular piston, if you look at it, you can see there are reliefs cut out, so when the piston is on its way up and a valve is open, there's clearance still. So that's interesting. The last piston I have is from a 2-stroke engine. This was from a still. I think it was a chainsaw or a cut quick or something like that. Anyway, this is very much, it works the same way as pistons in a 4-stroke engine, but since it's a 2-stroke engine, there has to be a valving arrangement for the 4 events. And the way it's done in this particular engine, this is called a piston ported engine. And as you can see in the piston skirt, there are ports. There's a port here, and there's a port here. And what happens When the piston is on going up in the cylinder, it creates a vacuum in the crankcase, which draws in fuel and air. When the piston is on its way down, it pressurizes the crankcase and forces that fuel-air mixture up into the combustion chamber through transfer ports in the cylinder. Combustion occurs and the process repeats. The interesting thing is this process repeats. Some of the fresh charge that's admitted to the cylinder is used to scavenge some of the exhaust gases. So I think that's a very interesting application of a piston. Okay, well, thanks for watching. Thanks for listening. Have a good day, guys.